All right, so this is the second part of 7-7. So in the homework, it would be like number 15 on is really kind of dealing. We're still doing the same numbers that I had originally assigned, which were 1 through 25, and then 35 through 40. Okay, so you can do 15 through 25 now after watching this video, and 35 through 40. All right, so perfect square trinomials, or trinomial squares is another way to put it. That is when we have, let's just say go back to about a week ago. If I have a square that looks like this, and I wanted to find the area, we could use our area formula and basically square the binomial. Now remember, we don't distribute the exponent. We are squaring the binomial. So when we do that, remember we can FOIL it and do our first ones or double distribute. 2x times 2x is 4x squared. 2x times 3 is 9x. Is 6x. Then we have another 3 times 2x is 6x. And then 3 times 3 is 9. So we add it all together and combine like terms, we get this. And that is what we call a trinomial square, perfect square trinomial. Where the first term is a perfect square, let's look at the characteristics of it. And within a perfect square, okay, so we'll come back and look at it. So let's practice that. One shortcut that I showed you last week was we square the first term. It's x squared. We square the last term. It's 25. And then remember, we're going to have two inner and outer terms. So when I have x plus 5 and x plus 5, when we're FOILing, you've got your inner term, which is 5x, and your outer term, which is 5x. Multiply the two together, then double it. So 5 times x is 5x times 2, because we're going to have 5x and 5x, inner term and outer term. So that would make 5 times x is 5x, double it, and we get 10x plus 10x. Okay? Now, if I do the same thing, remember, we square the first term, m squared, we square the last term, 4. And then if I multiply them together, I get negative 2m. And when I double that, I get negative 4m. Remember, squaring that term is negative 4. Negative 2 times negative 2 makes positive 4. Let's try it again. Square the first term. It's 4x squared. Square the last term. It's 49. Phone call came in. So here we go. Square the first one. It's 2x squared. It'd be 4x squared. Square the second term. It's 49. Right? Second one, it's 49. And how do I get that middle one? Multiply it together and double it. 14x times 2 is 28x. So why don't you pause the recording and try the next three on your own. See if you can do it the shortcut way. If in doubt, you can always double distribute out. Now check your work. We've got, if I square 2k, it's 4k squared. If I square negative 5, it's 25. Multiply all together, both of them together, I get 2k times negative 5 is negative 10k times 2 is negative 20k. Now remember, when I multiplied that negative 5 times negative 5, it's a positive 25. Okay? 3t is 9t squared. This one's going to be 16. When I multiply them together, it's 12t times 2 makes 24t. Don't forget that plus 16. First one, square this, it's 121. Square the next one, it's plus y squared. When I multiply them together, it's negative 11y. And I multiply that by 2, so it's negative 22y. Okay, so that was the shortcut that we learned yesterday. last week, sorry. Now let's move on to, but remember, if in ever doubt with these perfect square trinomials, you can always use X marks the spot. Okay, so one of the things I want you to learn are the formulas. The quantity of A plus B is really, so the pattern is we square the first term, we square the last term, and then we multiply the two terms inside the binomial by each other and then double it. Please make sure you know that. I'm going to give you a quiz on that. If I'm doing the same thing for a difference of squares for binomials, it would look like this. I would also like you to learn this one. Remember, the square root of A squared is A. The square root of B squared is B. And we have a plus and a minus. So these two formulas are ones that you should know. Okay, so we quiz you. So remember, let's look at how they explain it. The last term, if I square it, if I square it, I get the last term in my trinomial. If I double it, I get the coefficient of the middle term. Okay? So, one thing I always do when given, now what we're doing today is really the back end of that. I'm going to notice that both of these are perfect squares. So, I'm going to make it look like this. What's the square root of 36? It's 6. What's the square root of m? It's a positive. When I multiply, and then I'm going to check myself, because they will give you something that looks like a trinomial square, but it's not because of the middle term. The middle term, I have to multiply the two terms together, get 6m, and then double it. Remember to get that inner and outer term. And so that would be times 12m. Because 12m is in the center, this is the correct answer. So let's try it again. Square root of 49 is 7. Square root of y squared is y. To get that minus 14, I'm going to have to put a negative in there. And now I'm going to check myself. Negative 7 squared is 49. Y squared, negative 7 squared is positive 49. Y squared is positive y squared. And then when I multiply the two together, I get negative 7y, double it, and I get that negative 14. So that is the correct factoring. Remember, we're looking for the factors. And so what that means is that y minus 7 times y minus 7 is equal to that original trinomial of y squared. Remember, we can write it like this or like this. Either way is fine. All right, so let's practice it. Okay, so together we'll start. Let's start with, I'm going to make my binomial. I just make it like this. The square root of 4 is 2. Square root of x squared is x. And then I know it's because there's a minus sign. The only way to get a minus sign is if there's a minus there. And I can check myself. This works. 2 squared is 4. Negative 2 squared, x squared is x. Negative 2 times x is negative 2x. Double it gives me my middle term. Okay? Why don't you pause the recording and try it on your own? Okay, now check your work. So we've got 25. The square root of 25 is 5. The square root of y squared is y. It's plus plus, so it has to be plus. I know that when I multiply my 5 and my y together times 2, I get the middle term, so that is correct. You can also double distribute out and see if you get it. Okay, the square root of t squared is t. The square root of 81 is 9. It's minus and it's squared. Y, 10, it's positive, so does this work? 10y, double it, I do get 20y. Okay, that works. All right, next one is 2x and 3. It's got to be a minus sign if there's any kind of negative in it. And then I end up with 2x times negative 3 is negative 6 times 2 gives me that middle term, so that's the correct answer. Next one is m. I've got 28 is not a perfect square. So let's see if I can use my x marks the spot. I can't use perfect square trinomial. It's not a difference of squares because it's 3 terms. So I'm going to check what multiplies to 28 and adds to 14. Well, we know 7 and 4 multiply to 28. How about 14 and 2? But they don't add to this, and neither does 7 and 4. And that's it. So this is what we call not factorable. Then we've got our t and 4. It's got to be minus. When I multiply those two together, I get negative 4t times 2. Gives me the middle term, so we're good. And then the last one, I'm going to try the square root of 9k squared is 3k. The square root of 4 is 2. And so when I multiply those together, that becomes 6k. Okay, double that, 12k times 2. Does that work? Does that give me the middle term here? No, it doesn't. So actually, this is not a perfect square trinomial. It cannot be factored, not as far as we know at this time. This is not the right answer, and we are going to write not factorable. Okay? Questions? Okay, try the next few on your own. Let's go. Pause it. Do them on your own. Okay, now check your work. Number 1, you should have gotten x, the quantity of x minus 6 squared. Number 2, you should have gotten the quantity of y minus 7 squared. Number 3, the quantity of t minus 1 squared. Number 4, k minus 11 squared. Number 5, 2x plus 7, that makes 14x, double the center. Yep, that works. And number 6 is not factorable. Now, remember, let's try this. Let's complete the square. So, when we are completing the perfect square trinomial, basically we know the number times 2. So if you just, since we got that middle term by dividing by 2, multiplying the middle term by 2, let's divide it by 2. And we get when I take 6x, the middle coefficient, I divide it by 2, I get 3, and then I have to square it. And we get our last term. The middle coefficient, divide it by 2, then square it, it would be 36. Pause the recording and try the last 3. Okay, now let's check our work. Sorry about that. For number 3, okay, so again, the middle term, we know that if we divide it by 2, we get x plus 3. And so that would be 3 squared is 9. Divide the 12 by 2, we get a 6, so it would be m plus 6. Squared would be 36. Same thing. We're just doing the same thing. It just looks a little bit different. I know if I divide this by 2, I get y minus 9. We know that when we All I did before was just take that negative 18, divide it by 2, I get 9, and then square it. And that gives me my 81. Okay, we know that this is going to be k, divide the 14 by 2, and we get 7. We know this is going to be 49. Okay, now I want to say, first of all, I know that the first term has to be what? It's 2t. This is a little bit trickier than the others. If that's 2t, when I divide that by 2, I get a 10t. So what must go here to make it equal to 10t? What must be multiplied there? So I would have to be, if I divide that by 2, I end up with it would have to be a 5, right? So because 5 times, now it's going to have to be a negative. 2t times negative 5 is negative 10t. We're going to double that. We get negative 20. And so what's this last one going to be? It should be 25. 25. Okay? Was a little bit tricky. One more time. I looked at the first term. I knew the square root of 4t squared was that 2t. Then 2t times something had to equal negative 20t divided by 2. So that would be a 10t. 2t times what equals negative 10t? Would have to be a negative 5. All right, so now let's add it all together. We're going to be like working with these fractions with factoring. And so the first thing you're always going to ask yourself, let's add one more step to it. What is the GCF? Well, the GCF has a 5 in all terms, and then I'm left with x squared plus 15x plus 9. Okay, now oh wait, 3x, sorry. Whoopsie. I was like, wow, that's not working. So 5 divided by, it's going to be a 6x, sorry. And so now what I'm noticing is that this is a perfect square, trinomial, because the first and last terms are perfect squares. Now, if I don't recognize that, you can always go to your, what multiplies to x, do your x marks a spot and put the product of the last term and the middle term here, and we know it's 3 and 3. X plus 3 squared. But right away I recognized that pattern. They were first and last, and the center was 2 times the root of 9. So next one, a little bit different. There's no GCF, but what we have is x squared. And I know that one's going to have to be minus and plus because, or minus and minus. This is a perfect square. This is a perfect square. So let's say 4 and 4. To get that negative, I'm going to have minus minus. So now, let's see. Does that makes negative 8x squared. That makes negative 8x squared. And so that makes, it's not working. Let's see. Hold on. Okay, I caught my mistake. It makes negative 4x. Whoops. Makes negative 4x and negative 4x. They both add to negative 4x squared. They both add to that middle term. So that works. But see, what we are left with now is what? What do we call that when I have a binomial with 2 perfect squares and a different sign? It's called a difference of squares. And you only get full credit if it is fully factored. A difference of squares. Okay, this factor, whoops, let's do this. Their writing is much neater. So let's do theirs. X squared minus 4, remember that breaks down to x squared minus 4, and that becomes x plus 2, x minus 2. x plus 2, x minus 2, which is called a difference of squares. And so we can now write it like this. All right, let's try practicing a few more. Pause the recording. Now check your work. Hopefully on number 1, you noticed there was a GCF of 3. And then we can factor that perfect square trinomial to x minus 4 squared. The quantity of x minus 4 squared. Okay, the next one looks like it's x squared minus 1, which I must say that is really means x squared minus 1, and we are left with 2 sets of difference of squares. So x squared minus 1 is a perfect square minus perfect square, so that becomes x plus 1, x minus 1. And the other one is x plus 1, x minus 1. So we can write that as x plus 1 squared times the quantity of x minus 1 squared. And that's the lesson.